With resources being diminished around the world, sustainability has become a focal point of society. As such, Australia has been drawn to water sustainability as the issue of water conservation grows. One particular area of water conservation is the repurposing and recycling of wastewater. Wastewater repurposing involves the separation of the elements of the wastewater to produce reusable byproducts and renewed water to be used again. However, this does not come without its own risks. Not all the byproducts produced are usable and safe, and not all the methods are cost-effective and efficient. As such, a team of researchers, one researcher, myself, aim to document the enigma surrounding wastewater repurposing and discover whether or not it is the answer to Australia's water conservation problems. We begin by exploring Australia's past water usage from 2004 to 2005. The Australian Bureau of Statistics found that only 425 gigalitres of utilised water consisted of repurposed water. Furthermore, 79,784 gigalitres was drawn from non-renewable sources of water, a worrying statistic reflecting why water sustainability is crucial to the future. Wastewater repurposing aims not to produce an entirely new water source, but rather take a water source that has been used and then to cleanse it of any impurities. As part of this process, beneficial byproducts known as biosolids can be produced. They contain all the remaining nutrients and organic material from the waste to be reused for fertilisation of the land. They also contain trace elements and moisture, making it a perfect fertiliser for both farms and fauna due to its composition. The disinfection of the wastewater is achieved through three main methods: chemical, physical and biological, as outlined by the Environmental Protection Authority of Victoria. Chemical disinfection involves methods such as chlorination to sterilise wastewater, which is a quick and effective method. However, it does result in the byproducts being unusable. This method is also costly, with the chemical itself becoming a toxic byproduct of the process. Physical disinfection uses techniques such as microfiltration to remove the waste and the water from each other, isolating the elements to use the biosolids and the water. However, this technique also has a high capital cost. Biological processing of wastewater involves the isolation of the wastewater. However, this does run a risk, as it does not completely kill all pathogens in the water on its own. However, it also produces usable biosolids as well as it being a cost-effective method. The further research was conducted, it became clear that each method had both its positive and negative attributes, with there being no clear best choice. However, it was clear that the methods were a step in the right direction to improving water conservation and eventually creating sustainable water sources, but not the answer to Australia's needs. The need for such has grown in recent years, with prolonged droughts affecting both regional and urban Australia, as they also increase in frequency. Furthermore, our old water habits have been wasteful and diminished our natural water resources, as reflected by the Australian Bureau of Statistics, with the rise in water bans emphasising our water crisis and the need to become a nation with water sustainability. Although the number of people participating in water-wise methods have risen, the current techniques focus on the conservation rather than sustainability, such as water waste repurposing, reusing water but not actually creating a sustainable source. Creating awareness is a good focal point for improvement, but research into new areas of water sustainability is to ensure water is available for future generations.